For joining us today on the Weather Classroom, Jill Brand and Mike Bono with you. We're here every weekday at this time, and each weekday we have a different focus. Today our focus is seasons. Basically, why do seasons occur? When is the change? Mike Bono is going to cover all of that for you. And then we'll take a closer look at the jet stream in the season. Why does it change? And what does that mean to where you live? So you maybe take a bit closer look at the jet stream next time we show it on the Weather Channel, and hopefully you'll understand a little bit more. And we also have our weather history segment today, and that is about the 93 hurricane season. You know about the 4 main seasons. Now we'll talk about the hurricane season. And all this week we're taking a look back at the big weather events of 1993. So today in our weather history segment, it's the 1993 hurricanes.
One of the key factors which causes the change of seasons is the angle at which the sun's energy hits the earth. Bill Keneely explains.
In late December, the sun is at a low angle to the horizon for the northern hemisphere. Therefore, the sun is not above the horizon for long each day. The nights are longer and the air is colder. The sun's energy doesn't have as long to warm the atmosphere. But by early April, there is approximately a 30-degree difference in the angle of the sun at midday. This allows for longer days and more sunlight to warm the air. Also, because the sun is at a higher angle, its energy doesn't bounce off the Earth's atmosphere as readily. In winter, that bounce effect also keeps the sun from keeping us warm. By June, the sun is 17 degrees higher in the sky. Besides longer days and less atmospheric bounce, the sunlight is also more concentrated. The concentration is much like holding a flashlight straight above your hand and then holding it at an angle to your hand. Overhead, the light is concentrated. However, at the angle, the light falling in your hand is less concentrated and not as bright. Bill Keneely, the Weather Channel.
Well, today's focus story is seasons, and we'll take a look at what causes the seasons. First, picture the Earth as being out in space, rotating or revolving around the sun. And this is what it does. It goes in this direction. In fact, really all the matter in the universe, or at least in this galaxy of ours, goes this way, kind of around a center of the universe, or a center of the galaxy again. And the Earth goes this way around the sun. The sun even rotates. The Earth rotates around its axis. So that's the way we're turning around right now. Now, winter came just about a week or so ago, December 21st and 22nd, the Earth revolving around on its axis, and the axis pointing toward the North Star. The North Polar axis pointing toward the North Star all the time in all of these pictures. So it's like a gyroscope going round and round. And when the sun hits the Earth on December 21st, 22nd, it shines more intensely on the southern hemisphere than on the northern hemisphere. In fact, the Arctic areas never even get the sun on that day. Now, by the vernal equinox, March 21st and 22nd, the north and south poles are just barely illuminated by the sun, and the equator has the sun right overhead. So everybody gets 12 hours of daylight, 12 hours of darkness, whereas the southern hemisphere gets the longest days here. And then by the summer solstice, the northern hemisphere gets the longer days, and the northern Arctic regions are in the sun all the time, whereas they never get the sun down in the Antarctic regions. Come around to the autumnal equinox, late in September. Well, one side of the Earth being dark, but again, North Pole and South Pole just getting the low horizontal angle of the sun, and the equator gets the full tilt with equal day and night. That's equinox. Equal day, equal night, 12 hours each. So in the summer, the equator is actually south of the direct rays of the sun. The sun's direct rays hitting the Tropic of Cancer, continuous daylight in the Arctic, and higher sun angles and longer days in the north, lower sun angles and shorter days in the south. In fact, we even have a seasonal lag. Even though we have the longest day of the year on June 21st, the strongest sun's rays, the highest sun's rays, the average temperature actually gets the highest in late July. That's called a seasonal lag, a little later than the best sun. The winter solstice, the equator tilted this way, the sun's direct rays hit the Tropic of Capricorn, and the more, say, acute rays hit the northern hemisphere. So we have low sun angles, and the North Pole is faced away from the sun and never even gets any sun.
There are other seasons to consider in weather besides the 4 main seasons. Charlie Welsh talks to us about the most dangerous, the hurricane season of 1993.
The 1993 Atlantic hurricane season had only 8 named storms. In an average year, there are 10. The first storm of the year developed on June 18th and was Tropical Storm Arlene. The storm caused heavy flooding in Mexico, coastal Texas, western Louisiana, and Arkansas. 6 people were killed and damage was estimated at over $22 million. Tropical storm Brett formed in the Atlantic east of the Windward Islands. Winds and heavy rain led to extensive flooding and mudslides around Caracas, Venezuela. 184 people died from Brett. Tropical storms Cindy and Dennis did not affect the U.S. mainland. Emily was the only major hurricane of the season. It formed in the same location as Hurricane Andrew, so the storm caused anxiety along the eastern coastline. The storm approached the Outer Banks of North Carolina with winds of up to 135 miles per hour.
People have already been evacuated. They're riding out the storm. Areas are boarded up right now, and all they are is just sitting it out and waiting with it, as we are with the Weather Channel, as the storm continues to pass now directly to our east and continuing to move parallel to the coastline on off towards the north. Jeff?
The storm did stay just east of Cape Hatteras, but residents living on the island felt the wrath of Emily.
Now, the main devastation that we had from Hurricane Emily was really caused when we got strong west winds across Pamlico Sound after the hurricane had actually moved a little bit north. And what that did, it carried some very high water into Hatteras Island, and it got 10 feet above sea level on the sound side. Now, on the ocean side, the tides are much less, only 2 to 3 feet. But the main damage there on Hatteras Island was really caused by this storm surge that came in from Pamlico Sound.
Over $35 million worth of damage was done, and 3 people lost their lives from Emily. Hurricane Gert brought heavy rain and flash flooding to the southwestern Caribbean. The storm made landfall near Tampico, Mexico. Gert killed 76 people. The last storm of the season, Harvey, stayed well out in the Atlantic. Although the '93 hurricane season will be remembered as being relatively uneventful, the storms killed 280 people and caused millions of dollars worth of damage. I'm Charlie Welsh, the Weather Channel.
One of the most beautiful seasons in the year is autumn, when the leaves turn colors. Dennis Smith explains how the trees change into fall splendor.
As autumn days grow shorter and shorter, the amount of available sunlight decreases. The photosynthesis process in the trees slows down. Less chlorophyll, which makes leaves green, is produced. Many believe the first frost is responsible, but some leaves start to change before this event. Weather plays an important role. Warm, sunny days followed by cool nights. The cool nights trap the sugar in the leaves, and the warm sunshine helps to bring out the different pigments within the leaf. Different pigments form different colors. The aspens, which cover the Rocky Mountains, transform the landscape into a sea of gold. The maples show shades of majestic yellow, orange, and red in the Appalachian mountain chain. The kaleidoscope of colors is one of the signs that winter is just around the corner. Dennis Smith, the Weather Channel.
Alrighty, now let's take a closer look at how the jet stream changes places during the seasons. If you've watched the Weather Classroom before, you've probably seen our explanation of the jet stream. What you really need to know is that the colder air is always north of the jet stream. So in other words, the farther south that jet stream comes, the more cold air there's going to be in the United States. Now, it's generally thought that the polar jet stream divides basically the mild air to the south with the cold air that we like to keep up in Canada. During the summertime, it can come a little bit south of the U.S. border, but in wintertime, it can come all the way down to the Gulf Coast and even into Florida. So in the summertime, with lots of daylight up here, it's cold, but not that cold. In the wintertime, remember, the Arctic Circle is in 24 hours of darkness through most of the season, so the cold air builds up, and that drives the jet stream farther to the south. So what do we get here in the U.S.? Well, we get a lot of cold weather, of course. Today's jet stream shows the polar branch all the way down to the Gulf Coast and even an Arctic branch coming south, so a lot of cold air in place today. And if you want to learn more about seasons, check your book under Chapter